This time we talk about toolchain in Bazel. We started by explaining what is a toolchain in the Bazel's perspective. This shows how the target is being built in Bazel. The rule takes in the source files, perform a sequence of actions, and then produce the output files. In some cases, you want the actions of a built-in rule to behave differently. For example, you want to use the same compiler but a different linker, or you want to provide the same source file but produce the binaries for a different target platform. With the information above, we can define a set of parameters that affect the rule's action can be called toolchain. I can quickly show you how to write the toolchain in Bazel. This page from the Bazel official guideline assumes you are writing the toolchain for the bar binary, and I have summarized the following steps for you to refer in. The first step would be create the language-specific toolchain rule. In our case, we have to create the bar toolchain, which provides a toolchain info in the provider. The attributes of the toolchain rule shall pass the parameters that can determine the behavior of the building process. For example, the compiler path, the system lib, and the architecture flags. The second step would be create the toolchain target in the build file. You need to declare the toolchain type, which serves as a tag for the specific toolchain. You need to create the target bar toolchain with the parameters of the building rule. And eventually, you need a toolchain target that refers to the toolchain type and bar toolchain above, with also the execution platform and target platform. Here, I show you in a real-world example an LLVM CPP toolchain that I implemented for illustration. In the bottom of the build file, you can see the toolchain rule where you declare the execution platform and target platform. Also, the toolchain type has been provided here. You don't need to define your own toolchain type for all the C or CPP language rules because Bazel tool repos already provided one for you. Above, you can see the CC toolchain rule, and that is an actual language-specific toolchain rule you need to use. There is a little surprising here because you see another big chunk of code in the top of the build file. That is because the CC toolchain depends on another target, which is called CC toolchain config. So for the C or CPP language-specific rule, the actual toolchain parameters are defined in the CC toolchain config. If you wanted to know how CC toolchain config can be configured or what are the actual parameters I should fill, please click the link here. Now I want to give you some hintings. The CC toolchain config and CC toolchain are Bazel built-in rules. You definitely have the flexibility to write your own toolchain rule to replace them, as long as your implementation is compatible with CC binary and CC library. To use a toolchain in a Bazel build, you have to register the toolchain. You can either register toolchain via the module file by calling register toolchains, or you can pass the toolchains via extract toolchains option in the command line argument with the build. If you have multiple compatible toolchains, and here the compatible means the execution platform and target platform matches this build, Bazel gonna perform the toolchain resolution for you. If you want to show the process of the CPP toolchain when building the target, you can pass toolchain resolution debug with the toolchain type target. After the introductory part, I wanted to show you how Bazel generates the default toolchains for you. There is no magic and everything has a trace. You already know that Bazel requires you to declare the external dependencies in the module file. However, these dependencies are not all the dependencies that Bazel is going to use. Bazel internally implicitly depends on some other dependencies. You can see all of them in the Bazel log file. For each programming language, Bazel depends on an external dependency, for example, rules CC, rules Java, or rules Python. You can see they have been declared in this module log file. You don't have to explicitly include those dependencies in the module file because they will be automatically used when you build the CC library, CC binary, or Python library targets. Next, I will show you how Bazel actually generated the default toolchains. There is no magic here at all. If we type Bazel ISK info, then you will see a lot of things has been declared here. We are interested in the output base. Let me open this folder. In the external folder, you can see a lot of things has been already downloaded, and they mostly matches what you see here in the log file. Next, I'm gonna show you how the toolchain has been resolved to the default toolchain. I need to guarantee I have commented out the Bazel register toolchains are not in use, so the default toolchains provided or determined by the Bazel are being used, not any toolchain that I implemented. I'm going to build the EX0 target with the toolchain resolution debug enabled. Okay, now we don't see anything because the folder, the building cache already exists. So I need to Bazel ISK clean. Now I build CPP example 0 again. Now you can see how the toolchain has been resolved. Here we can see some printout, CC compiler ARM ABIV7A. I don't know where it is located, so let me search in here. Wow, I can see a lot of things in the toolchain template. And where is that again? Okay, so let me narrow down my search scope. What about here? Toolchain, okay, not yet. Then this build file. Okay, so in the build file, in the cc config extension load config cc, we can see the cc toolchain target is actually declared here. And also, maybe, how about this one? The compiler. Yes, this one, this toolchain target, cc compiler Darwin ARM64 is also defined here. Here you can see the cc toolchain config example is actually here as well. And these codes are auto-generated by the rule cc extension by some repository rules or module extension. If you wanted to implement your own toolchain, and this can be a very good example how you can fill those arguments. Next, I still wanted to search where is actually the top level toolchain target. You can see the high-level toolchain target is also generated here with the execution platform and target platform. The host constraints are also auto-generated. In the toolchain resolution process, 2 toolchains has been found for the CPP rule. I wonder where are those toolchains being registered? It actually happens here in the rule cc module.bazel file. You can see register toolchain local config cc toolchains all, which means so every toolchain here, in total we have 2, are being registered.